Hey everyone, last time that we talked about lecture material, I was going over a little bit about how to write Java and how to write classes in Java in particular, but we kind of skipped over some of the more basic aspects of Java, such as what it is and why we would even use it for this course. In particular, why would we use Java over maybe say C++, which you're probably more familiar with. So in this video, we're going to go over the history of Java and what Java the language actually is, and in the following videos we'll go over a little bit more about the specific language constructs and some other things that are important and inherent to the Java language. So here today we're going to talk about the history of Java. In particular, this is just going to be a brief history over what it is and why it exists. So it was created in 1991 by Sun Microsystems. It was designed for appliances, and at the time, appliances had a wide variety of processors, and this made it difficult to develop and compile code because it all had to be developed in a different way. It all had to be in particular compiled in a different way. So Java was created as a two-step translation process to simplify the development. It was a write once and run anywhere philosophy. So the code itself would never change. It would always be the same no matter what platform it was running on. And the only thing that would be different is the compilation from the bytecode from the Java JVM, as we call it, to the machine that it was running on. So what this means is we would have the source code. So the source code would be what we write. This is normal source code, nothing special about it other than the language that you're using. It would go through a Java compiler. Now this Java compiler wouldn't spit out an executable program in and of itself. Instead, it's going to spit out Java bytecode. Now this bytecode is really important part because this is what the JVM actually reads. So far we have the source code turning into bytecode through the Java compiler, and the JVM is doing what exactly with that bytecode? That bytecode is really important. That's your program and its compiled format, but the operating system doesn't by default know how to use that. So what the JVM does is it actually translates the bytecode to the operating system, but not only does it do that, it also translates the operating system commands and information back to your program so you can actually use system calls within the JVM and within your source code. So that's really important. This process is very different than how it would work in C++. In C++, you would compile your source code straight into an executable that's run by the OS directly rather than through some sort of translation process, which means that if you're running it on a different operating system, you have to compile it differently. And that takes a lot of time if you're trying to deploy to a lot of different types of operating systems, which isn't as much of a problem now because we use a lot of similar operating systems across all of our devices, but at the time it was a really big deal. So what else is different between Java and C++? Well, first of all, Java has memory managed by that JVM that we mentioned. A garbage collector will come and deallocate any memory that you're not currently using and not using in the future. Objects in this case are just variables. We talked a little bit about objects last time, but they actually work very similarly to variables. They're not anything particularly special in the way that Java sees them. In C++, explicit memory management is handled by you, the programmer, and pointers are an important aspect of that process. In Java, there are no pointers that you explicitly handle. They're all implicit to the machine itself. Also, in Java, you have a single file per class, which also limits us in some ways, but let's start with how that's different from C++. So in Java, you have a single file for every class that you have. In C++, you have to have at least two files. You have a header and you have an implementation file. In Java, we do all of the implementation in the same file that we would declare it. What's also interesting about this is the order of functions doesn't matter nearly as much in Java as it does in C++. If you call a method or a function in C++ that you did not previously declare, which is why the header file is so important, then you're not going to be able to to actually use that method unless you've had it declared. In Java, that doesn't matter as much. The order of our methods doesn't matter as much. If I want to use a method that I define later in the file, I can actually do that. The other thing that happens here is we only get single inheritance. We can only inherit classes from one parent rather than in C++ where we can get multiple inheritance. And we'll talk more about inheritance next week. So we're not going to worry too much about what that exactly means, but just keep in mind that in Java, you can only inherit things once from one parent, and in C++, you can have multiple levels of inheritance. We also get the use of interfaces in Java. This is kind of how we replace that multiple inheritance. It's a little bit different and not quite the same, but we do get to use interfaces to provide multiple levels of abstraction that we would maybe just do with classes in C++. Java also has no overloading of operators. So if you like to overload operators such as plus or minus or your comparison, you don't get to do that in Java. So keep that in mind when you're building your classes and when you're writing your programs. In addition, we have a different type of structure to our programs. There are packages, and import is a keyword that you're going to see a lot. In C++, instead of import, you would have include. The packages are less important to really understand. Just understand that every Java program, every set of source code that you're going to write is going to belong to a package. And you can share code between packages. It's just not going to be typical in this particular course. And lastly, we have, I want you to take a look at a previous C++ project that you wrote. Just take a few minutes, it doesn't have to be very long, and I want you to look at it and try to decide if there are parts of it that would maybe have been easier if you wrote it in Java, or something that was easier because you wrote it in C++. I want you to really compare and contrast what you know about C++ with Java and what you know about it, and in particular, how you think it would be to develop in these two languages.